Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Sam Moulton from the Business Review, and I'll be your host. It's our pleasure to have VTT and Fortum with us today, who will be discussing the topic, Experience Your Future Thermal Power Generation. This is a unique opportunity to learn from a leading R&D organisation, VTT, and a world-class service provider, Fortum, in one session. Today's guest speakers are Perttu Jukala, Senior Scientist at VTT, Anu Mikkonen, Research Scientist at VTT, and Antti Hinolainen, Product Manager, Environmental Performance at Fortum. I'd like to welcome you to our webinar platform On24. You'll notice that it's browser-based, so if you disconnect at any point, just click on the link you received via email to rejoin. You can send in questions as well. You can do this via the Q&A widget at the bottom of your screen, or use the questions box at the top left-hand corner. We'll try and allocate around 10 or 15 minutes at the end of the session to address any of your questions or thoughts. If you click on the survey widget, a few questions in there for you to answer. So you can do this during or immediately after the webinar. If you require help at any point, you can click on the yellow help widget for assistance. You can move and resize and maximize any of the windows in front of you to get a better view. But for now, please allow me to welcome Perttu.
Okay, how do you do? On behalf of VTT and Fortum, welcome to all of you to follow our webinar. My name is Perttu Jukala. I'm from VTT, and I'm specialized in computational fluid dynamics modeling of combustion systems and the related process analysis and process development.
Hello, my name is Antti Hinolainen, and I'm a product manager for combustion technology in Fortum, and mainly our expertise is the low-NOx combustion, and for that we have a long cooperation with VTT.
Hello, my name is Anu Mikkonen. I'm from VTT, and I'm a research scientist and also product manager at VTT. My work includes simulation, modeling, control systems, and so on. I'm also updating our pilot systems in Jyväskylä city, in the middle of Finland.
Okay, this is Perttu again. This webinar deals with utilization of modeling and simulation techniques in design and development of thermal power generation processes related to the challenges they face today and in the future. For that purpose, we will present you 3 concrete case examples how modeling and simulation can be applied in real cases to aid in design and analysis. The first example is about emission reduction in fluidized bed combustion. The second example is about conversion of a PC boiler for leak gas coal-firing. And the third example is a dynamic modeling study of a hybrid energy system consisting of a conventional power plant and a solar energy module. But at first, few words about VTT and Fortum. VTT is a research and technology company, a leading one in Nordic countries. We are a non-profit organization fully owned by the state of Finland. We provide expert services to our customers in private and public sectors, both in Finland and abroad. In the field of energy, or more specifically in the field of bioenergy, we have a strong expertise in thermal conversion techniques, in combustion, gasification, and pyrolysis. We have test facilities, and we offer modeling and measurement services and do different kinds of concept studies and evaluations.
Antti Heinonen, Fortum. Few words about Fortum. So, Fortum is a middle-sized energy company, power producer in Europe. We are a major player in nuclear and hydro generation. So we are located. We are located in Scandinavia, Baltic countries, Poland, Russia, and nowadays also in India. We have little less than 9,000 people working. Our sales last year figures from 4.7 billion euros. Part of Fortum is department Power Solutions. We have some 300 employees, and our core competence is the thermal, hydro, and nuclear power sector. And we are working in different type of solutions. Operation and maintenance is our operation and maintenance of power plant is one sector. We are references more than 20 countries. And second sector is the expert services that I'm coming from. And we have different type of expertise on our environmental performance, including low combustion and also thermal performance, turbine and generator overhauls, availability and condition management also. We have been cooperating a long time with VTT, and we see this is quite fruitful combination. So that VTT utilizing this combustion technology know-how on VTT and modeling, and also some measurement services from VTT combined together with Fortum know-how on boiler and combustion technology. So we have had a cooperation some 25 years, and we are utilizing in our cooperation the VTT personnel in the high-level modeling purposes. CFD calculation is the main key in our cooperation. We are providing, as Fortum, we are providing services to our internal clients inside Fortum and also external clients. And so far we have delivered a little more than 800 Lonox burners. Our cooperation includes different type of suppliers as a utility companies as a client, and also our cooperation with world-class boiler manufacturers too. How we see the market today, market needs and demand today. So let's summarize in this slide. So very much in Europe, we have this new emission limits coming in force in the beginning of next year. There are some transition period for certain companies to comply with these requirements later in coming 4 or 5 years. So emission limit or reduction emissions is one of the key components. Retrofit old boilers to be more efficient and environmental friendly way. And also what is coming more is flexible energy production, meaning that regulations, boiler has to be regulated more and more in the flexible load mode changes. And also what comes is different type of fuel mixtures, and also the biomass fuels with maybe co-firing in existing coal-fired units. As Perttu mentioned in the beginning, so we have 3 different cases here. And case number 1 we selected as an example of finding a low-cost solution for minimized emissions. This plant is located in the middle of Finland, Rauhalahti VFB boiler, and actually it's one of the biggest VFB boilers in the world. Originally it was a PT firing unit, and more than 10 years ago it was converted to VFB boiler. Main fuels of this plant are peat and wood-based biomass. Typically, peat is more than 50% and less is the wood-based biomass. Typical moisture content of the fuel is more than 50%. The challenge here in this particular case was to for the NOx emission, reduce the NOx emissions to the new IED limit. And in this plant, the limit is 200 milligrams per normal cubicle. And as an old plant, the target was to find a cost-effective solution for this, and we worked together with VTT and find a, let's say, two-stage solution. One is that we improved combustion, especially the air staging in the bed, to reduce the emissions, and then the second method was urea injection after this primary method reduction.
Okay, this is Perttu Jukola from VTT speaking again. Computational fluid dynamics modeling was applied in different phases in this project. First, it was used to develop the new air staging method in general targeted for VFB boilers. And then in the second phase, it was utilized to study and investigate this particular Rauhalahti case. Here you can see some results from our CFD modeling studies concerning nitrogen oxide formation in the furnace and the emission. On the left-hand side, you see the results from the preliminary studies where we demonstrated the potential of the new enhanced air staging technique to reduce the NOx emission in the furnace. The principle of this new technique is to optimize the air distribution in the lower part of the furnace for overall NOx performance. After these preliminary studies, the furnace was modified according to the principles that we suggested. And on the right-hand side, you see modeling studies concerning the realized system, simulated also with the urea injection. We were not able to go as low in NOx as we predicted in preliminary studies, mainly due to some process limitations and the change in fuel quality. But here we were able to demonstrate that by injection urea into the furnace, the NOx emission can be reduced below that 200 milligrams per cubic meter. Of course, when we do those emission predictions, we have to describe the whole combustion process in our simulations. And there are, of course, other topics that are interesting depending on the case. here are two examples what we have looked at in this Rauhalahti case. On the left-hand side, you see temperature distributions inside the furnace before and after the modification. You can see that the combustion clearly shifts downwards in the furnace in this new air staging system, so that we can much better utilize the low furnace for combustion and heat transfer, and with proper air staging to get the best emission performance without compromising fuel burnout or CO burnout. On the right-hand side, you see some examples of how we looked at furnace availability. Here, the main subject was furnace wall slacking in the lower part of the furnace. We had an intermediate solution for that enhanced air staging system that caused some particles to go to the furnace walls, and as the furnace walls in the lower part were refractory lined, that means that the surface is quite hot. The particles tend to stick to the furnace walls. In our optimized design, we manipulated the flow dynamics so that the particles keep away from the furnace walls, and then we reduced the refractory lining so that the walls above the fuel feeding points are now water cooled, so the walls are less prone to particle sticking. Those were the modeling studies, but then, of course, some experimental measurements were done. They were done in performance test studies with this enhanced air staging method combined with a temporary urea injection system. And the measurement showed that truly with this new technique we were able to reduce base NOx emission from 400 to about 300 milligrams per cubic meter. And with the temporary SNCR system, the emission went below to 200 milligrams. But now we have to state that the temporary injection system was not optimal in this case, as the ammonia concentration remaining in flue gas was rather high, indicating that the injection lances were located too far or too high in the furnace, considering the residence time and the temperature levels in the furnace. But in the simulations also we were quite nicely able to reproduce the measured results, and this case was used for model validation. We also studied different kinds of injection systems with our model, and we were able to show that by improving the reagent mixing and by relocating the injection points, we are able to still reduce the emission and have a better control of the ammonia slip in the flue gas.
Antti Heinonen, Fortum. As Perttu already mentioned about the results, and So this was, as a conclusion, this was a really good case where we could utilize modeling and get a feedback from the real process. And as a result, summarizing here, so by primary methods, we were able to reduce the NOx level from around 400 to 300, and by SNCR from 300 to less than 200 milligrams. And what was also important is that we didn't, let's say, spoil the boiler operation. So heat transfer was no change. Also CO emissions and fuel burnout was a good level. And the next step here in this particular case is that there will be we'll optimize the performance, and then there will be let's say permanent SNCR installation. Similar type of procedure, we have one reference in Poland with a PT firing unit, and we also make the same approach. So first we improve the existing primary combustion, launch combustion, and we were able to reduce the primary NOx really low level, so that the rest to reach this 190 milligrams per normal cubicle could be achieved or have achieved by SNCR. Then we have the second case. It's about expansion of feedstock in means by coal firing. Also, this unit it's located in Finland. It's a PT firing boiler, pretty old one. The thermal capacity is 560 megawatt cube. It's a very traditional hard coal firing unit, opposite wall firing furnace. In this boiler, we have a launch combustion system. We have a Lonox burners plus overfire air system. And 3 years ago, the boiler was retrofitted so that there was built a gasification plant, gasifying biomasses, and the gas from the gasification process was led to the existing coal-fired unit. The coal-firing capacity, so meaning the gas-firing capacity, was 140 megawatts by fuel, by energy. Here, in this case, the challenge, the target was to ensure the efficient and reliable operation of the furnace PC boiler when introducing such a big amount of gas firing. So the target was not to disturb the coal firing and coal firing process in the furnace. In Fortum scope, we delivered 4 pieces of lean gas burners, Lonox burners, and we were also involved in commissioning, and we were responsible for optimizing the system. Here we also utilized the CFD model. First of all, we are finding the best location of these 4 lean gas burners in the furnace, especially not disturbing the coal firing. And we also utilize the CFD tool as when we make the design for the lean gas burners. It's particular in this, it was tailor-made burners for this particular process.
Yes, this is Perttu Jukola from VTT again. So in the first phase, we studied the burner geometry by means of CFD modeling. And we had, in the beginning, we had the a base geometry that we fine-tuned with the CFD model to get the flame characteristic that we desire for the link gas burner. And in the end, we came up with a solution that predicted good flame stability. As you can see on the left-hand side picture, the fuel ignites in the inner region and also in the outer region, so from 2 points. So this proved to be true in real case also. So the experienced flame stability of the burners, link gas burners, has been excellent, which leads to the possibility to operate the boiler in gas-only mode at partial load operation, of course. On the right-hand side, you see a still picture of the burner in operation, and here we have also a small video captured from the gas-only operation of the burner. You see the burner opening in the left-hand side of the picture. This is now a quite short video looping 3 times here. And you are able to see the very good flame stability that the burner ensures. In addition to burner modeling, we also studied the whole furnace process with the CFD model. And we compared the coal firing mode to the coal firing mode, and also studied cases with different loads. We saw that as the burners were positioned in the lower part of the furnace on side walls in the hopper region, they affect the furnace flow pattern, and they a little bit reshape the coal flames also in full load operation. But after all the major output values from the boiler, heat transfer, burnout, CO, and the emissions were predicted to remain similar to the coal combustion case.
Okay, Antti Heinonen, Fortum. So here it's summarized the conclusion of this project. So basically what was designed was also achieved. So we could substitute 25% of coal with lean gas combustion. There was not a disturbance with coal firing. Of course, we make some optimization of the airs after modification, and the flame that was really stable, as you could see in the video, and also there was no side effect on the boiler normal steam cycle. In addition, in order to have this biogas firing, there was also reduction of NOx emission by 20 to 30%. Here we can also summarize that this was cooperation between modeling team and also with our burner manufacturing and burner design. That was done perfect way, and we get a good result of this project.
Okay, this is Hannu Mikkonen speaking from VTT. I'm going to tell you something about managing of load changes due to increasing solar energy, how to integrate solar power and conventional power plants by using APROS programming tool, which is owned by 50% Fortum and VTT. So as we have read from the news from, for example, Germany, wind power and solar power have been increased for many years drastically, and how to handle these peak loads and that kind of characters, which are new actually. So we have 3 points to develop this target. So this operating with these peak loads and base loads can be very hard. Secondly, is utilizing existing infrastructure, and thirdly, balance the distributed intermittent production. And these smooth changes in this during these load changes are very important. So analyzing and further improving, we have split these 2 and simulation boxes. So how to analyze and improve these tools are interactions between intermittent renewable power generation, traditional power plants. What are the methods, controls, and optimization tools and strategies to develop hybrid power plant concepts? On the simulation side, we have made a model from the CSP and conventional power plant. Actually, CSP power plant with 430 megawatt electric power and solar field, which you can see in the next slide. The power of the CSP unit is about 10 megawatts, but in this picture you can see this CSP power plant actually from the gas side, and here's the furnace side, and we are feeding in air from here, and also fuel from here, and sand and limestone, and this is from the gas side of this model, and here are the flue gases flowing out. As we know, one of the CFP combustion technology advantage is flexibility of fuel. We can use different fuels, and in this case, these CFP steam values were about 560 Celsius degrees and 275 bars. And this model includes all these needed equipments for water, steam, air, and flue gas systems. And with this model, we can make load changes, for example, stabilize the steam values and electricity production, and also control. We are using control system to handle these load changes. So this environment, of course, this is not so simple. It looks, we are using here article models. Every block includes lower model levels, and in this model we can see this is modeled as parabolic lens technique. And it includes also these weather models, which means that there's a solar power, and we can situate with coordinates this solar or this CSP power plant wherever we want in Earth. And these models calculate radiation and solar radiation and tracking of these collectors, which you can see here. And from this process, I can tell that this part of the process is preheating the feed water, and it's flowing into the tank where it is separated, steam is separated, and it's flowing to the superheating sections. And output steam is controlled by spraying water valves. So from boiler part, as I mentioned, this is furnace, turbine side, and CSP feed. So feed, in this case, feed water is taken from the boiler condenser part, flowing to the solar field, and steam is used for boiler feed water preheating to replace steam flow from the turbine tappings actually. So the power from solar feed is reusing this tapping, some of this high pressure parts. And they can be, when we are inserting steam to the boiler part, there can be some problems with emissions, varying gasification reactions, for example. There can be local hotspots, and of course the fluidization in the furnace also. So problems can be quite many. So here's the result part, which you can, in first picture you can see blue line CSP temperature about 500 degrees here, and red line CSP steam flow to the turbine about 20 kilograms, and these lights, you can see red line is steam from the CSP about 500, same earlier, and blue one is feed water to CSP about 90 degrees. Next, red CSP pressure is about, produced pressure is about 50-60 bars, and blue one flow to the CSP about 12.5 bars. And in this picture, you can see that when we are taking in the CSP field, it will change rapidly the load. And that is why, because steam pressure from the CSP has to be high enough. On the left side, in this slide, you can see condensed flow from the boiler to the CSP, and here are the main parameters in boiler side. And here you can see when we are using CSP steam or inserting to the boiler, it's about 10 megawatts difference in power production. So conclusions. In this case, there was this conventional power plant, the CSP plant was constructed, and it is an excellent base to study this kind of control issues and behavior of the system and both of the plants. And there can be a lot of problems which we can see by using simulation tools. These are these rapid load changes and these which can cause these unsteady combustion conditions, and further can lead to the unexpected emission formatation, gasification reactions, local hotspots, and dead fluidization, etc.
Perttu Jukola again from VTT. Coming to the webinar conclusions, we can say that together Fortum and VTT can deliver world-class solutions in boiler and combustion technology by combining our competencies in technology and modeling. And we have done cooperation for a long time already and have solid references from boiler retrofit cases that are based on modeling-aided approach. And we think that modeling is a very efficient and cost-effective tool to design burners and boilers and to analyze them and to study dynamical behavior of power plants. And modeling can also utilize it for troubleshooting, optimization, and process development purposes, for example. So we thank you for your attention, and we are now prepared to go for question and answer session.
So first of all, we're going to do a couple of poll questions for you. They're very simple and it's very easy to vote. So the first question is, did you find the webinar useful? And the answer is yes or no. To vote, you just click on the circle and then click submit. So I'll just give you a few minutes or a few seconds to do that, and then I'll move over and display the results. I think enough of you have voted now. And yeah, it's pretty overwhelmingly in favour of yes, 94% there. And we've got a second question before we go into the Q&A as well, which is, are you interested in utilising modelling to support plant operation or retrofits? And again, it's just yes or no, and you can vote in exactly the same way. Like when we do start our Q&A shortly, you can send in questions just by typing them into the white box at the top left-hand corner of your screen, and then by pressing submit. And yeah, then they'll arrive in our inbox. I think again, everyone's had enough time to vote for this question, so we can move over and have a look at the results again. And again, it's very positive as well. So 86% saying yes, they are interested in utilising modelling to support plant operation or retrofits. So if you could just comment on this before we go into the Q&A session.
Yes, this sounds exactly that what we are also as a technology provider. So we are happy to hear that our experience is it's something that we have relied on the calculation, CFD calculation modeling, and we are eager to supply our services also new customers. Thank you for your opinion.
Okay, thank you. So I'll start us off in the Q&A session now. First question, we've got lots of questions already. The first one I'm going to go to is, what is the effect of too much O2 excess air in boiler combustion optimization?
Yes, Antti Heinonen, Fortum. Yes, this is a good question, and it's obvious that when we are having two-stage combustion and we want to reduce NOx emissions, so we need to also reduce the boiler O2 excess as low as possible, and this sometimes it can be quite tricky taking account of these steam temperatures and we have to also take account possible for high temperature corrosion. But this is something that in all cases when we are doing launch modification, we also are decreasing this O2 content of boiler.
Thank you. Next question I've got is about the injection of urea. How is it done? Is it during normal operation throughout fuel burner? Understand that?
Yes, Antti Heinonen. Yeah, I can answer. So this is done. Yes, it's during normal operation. We have a special openings or lenses for urea injection port. So obviously we have to find a proper temperature window for the urea injection, and that's why we are modeling case by case the right elevation of those injections. So typically this injection port can be found in upper part of the furnace in about the overfire air nozzles.
Thank you. Next question is, what is the max power output of the CSP in the third example?
This is Hannu Mikkonen from VTT. It's about 10 megawatts. But what we can also adjust the power according to how many mirror lines we will add to the model. So we can, it depends, or it can vary from 1 to the 100 at the moment. So.
Okay, thank you very much. Next question is, the full CFD analysis appears to be very intensive and expensive analysis. Is there a shortcut alternative for simple evaluations?
This is Perttu Jukola from VTT speaking. Of course, you can apply some lighter process simulation tools, for example, but you don't get such a detailed picture of the combustion process that way. And I think, for example, this urea injection performance cannot be captured that way, for example.
Thank you. Next question is, can Outpost model solar tower?
Yes, we are working in this issue, and I think in a year it can. So, but it's under construction.
Thank you. Next one is optimization of SCR inlet position to reduce NH3 slip. Was it a trial and error, or does the model allow computed optimization?
Yes, Antti Heinonen, Fortum. Yes, this is we want to avoid the trial and error, and that's the reason that we are utilizing this modeling to find a temperature window. So from 950 to 1100 degrees is the proper temperature window, and that we will evaluate by the modeling, and these are giving us confidence that it will be, there's no need for trial and error on location.
Thank you. Next one, are there major differences in conversions when using different feedstocks, FEX, SRF versus forestry biomass?
Antti Helanen, Fortum. Especially the biomasses are very different type of fuels. So obviously there are big differences in different type of fuels. There's moisture content and also some alkaline content that can cause some trouble in the boiler normal operation. And I would say that biomasses are different type of, let's say, non-conventional feedstock has to be studied case by case.
Thank you very much. Next question is, what tool is applied for the CFD calculations?
Perttu Jukola from VTT. We apply the commercial ANSYS Fluent CFD code in the majority of our CFD analysis, but we usually equip it with the process-specific submodels that are developed by our own. In some applications, we also apply open source CFD framework.
Thank you. Next question I can go to is, how are the models validated?
The models are constantly validated based on the feedback that we get from real cases. We get feedback from full-scale boilers and furnaces based on the retrofits that have been done, and then we also get feedback from laboratory and pilot scale units that we use to validate our models.
Thank you. Where are the power plants located using this technology?
Antti Helanen, Fortum. So I understand the question about these references, the cases, what we described in the presentation with Perttu. So those two plants are located in Finland, but then we have also a couple of references in Poland, and those can be found more in our web pages or meeting us later. But those were in Finland, but they are also especially in Poland, we have a couple of references of SNCR utilization.
Thank you. So just a reminder now to the attendees, we've still got a few minutes to go, so please keep on submitting your questions to us. And the next one I'm going to go to is, what kind of client involvement do your services require?
Antti Helanen, Fortum. As Perttu described already, so obviously in the beginning we need let's say initial data from plant, so we have to build a model of the calculation grid of the furnace, including all let's say mechanical issues and also operational data. And after that we are typically making a kind of baseline tests or combustion audit to get the actual data what is needed for it, especially for modeling certain components in the process.
Thank you. Next question is, what is the biggest power plant size in terms of MW electrical on which an SNCR can be used?
I'm not able to answer what is the biggest. The biggest in megawatts, it's not mainly it's a question about the boiler dimension. So even a boiler with a small megawatts can have a huge dimensions, and the question is the residence time inside the furnace, and if there are places in upper part of the furnace to have place or space for this urea injection nozzles.
Okay, we've just got another question about Ura, which is asking whether the injection of Ura will affect unit load capability.
No, it doesn't affect. So the urea amounts are pretty small one, and so it doesn't affect on that.
Okay, thank you. Another question, a different topic now. Is Fortum oriented to Latin America?
At this moment, Fortum is not present in Latin America as a producer, but we as a power solution, we are globally we are able to work globally, and we can work also cases in Latin America.
Perttu Jokola from VTT. VTT is present in Brazil as we have a local office there.
Okay, thank you very much. Another question I've got is, the hybrid plant is a good idea, but do you have any comments on the financials? Is it worth the effort?
Hannu Mikkonen from VTT. If we are looking this daytime and nighttime, how to balance the production. Daytime we will have a lot of solar power, but where to put the energy? Of course, in the future, it can be put or modified into the gas, but nowadays it is not yet possible. So we need both plants to produce power at night and daytime.
Thank you. That's most of the questions we've got at the moment. We had one asking about whether the slides will be available, and they'll be available on the on-demand version. You'll be able to view or download them there. I'll explain how you can do that in just a sec. We've had another question come in now that I can go to, which is someone saying, we've had many accidents of boiler tube failure. Does your company capable to handle that problem? Is your company capable to handle that problem?
Antti Heinonen, Fortum. Yes, we have this kind of services as troubleshooting and issue. Yes, this is something that we can, and especially this is something that the modeling can be utilized to find out the reason for boiler tube failure, and yes, this can be done.
Okay, thank you very much. So I think that pretty much brings us to the end of the Q&A session and the end of the webinar. Did you want to talk about the opportunity people have to meet you now?
Yes, we could shortly present our presence. Okay, so we are present at PowerGen in Amsterdam in June, together with Fortum, where we share a stand. So you are very welcome to meet us there and have a discussion with us. So see you there.
Okay, thank you very much. So that just leaves me to thank Perttu, Hannu and Antti for what was a great presentation, and to thank VTT and Fortum for sponsoring this session. To all the attendees, you'll receive an email shortly in a couple of hours telling you how you can access the on-demand version of this webinar, or you can access this through our website, which is www.business-review-webinars.com. Like I mentioned earlier, you'll also be able to download a PDF version of the slides, or just view those in the resource list widget when you're in that on-demand version. If you would like to meet VTT and Fortum face-to-face at the PowerGen Amsterdam in June, or ask any further questions, you can do this via the survey once this webinar ends. It's been active during the webinar, but it's going to pop up in place of the page when we end now, so if you could take the time to fill out those questions there. We look forward to sharing further webinars with you, so if you keep an eye on the website I just mentioned, follow us on Twitter, which is @BRWebinars for daily updates, and join our LinkedIn group, Business Review Webinars. Apart from that, thank you once again, and I hope you all have a nice day.